All right, in section 1.2, we're going to look at scattergrams, also known as scatter plots, which is what I will tend to call them. Scattergrams is kind of a newer terminology. Scatter plots is what I learned, so sometimes it's kind of hard to change. But what we're going to be looking at in scatter plots or scattergrams is graphing data. And generally, we're going to have data that comes in pairs. We'll have something called an independent variable and a dependent variable. And we'll talk about those a little bit more here in just a minute. But when we graph data that comes in pairs, we graph them on a Cartesian plane, which is a fancy word for something I'm sure you've seen before. Cartesian plane is the x and y axis. Okay, usually we call this one x, this one y. All right, we label our axes, 2, 4, 6. Notice I'm labeling them by 2s. You can label them using any scale you want, really. Typically we'll go by 1s, but here I decided to go by 2s for no particular reason. Okay, this point right here, that one's called the origin. And then the axes are split into 4 regions, and up here we call this region quadrant 1, and this one's called quadrant 2, quadrant 3, and quadrant 4. Truthfully, the fact of the quadrants 1, 2, 3, and 4 isn't terribly important until you get into something called trigonometry. But nice to define it anyway. All right, so let's see. Now, we mark points here, and points here come as ordered pairs. So I might put a dot right there. This dot, notice we start at the origin, and I go to the right 4, and then up 2. So we call this the point 4, 2. And notice the left and right always comes first, and then the up and down always comes second. So this point 4, 2 is different from the point 2, 4. 2, 4 would be here. Okay, so the order here is very important, and so these things are called ordered pairs. Ordered because order makes a difference in pairs because, well, there's 2 of them. All right, a couple more points here. This point right here. This one is, start at the origin, you have to go 6 to the left, so that's -6. And then you don't go up and down at all, so that would be 0, -6, 0. And similarly, this point right here, this would be, you don't go left and right at all, that would be 0, -4. Okay, so right there, what I have drawn, that's a scattergram. A scattergram is just a graph of some data. What that data means, I don't know. It wasn't given in any sort of context, any sort of word problem. But there's a scattergram. Okay, so let's look at some actual data and draw a scatter plot. So here's problem number 42 from page 21. It gives you the value of a bill, and these are in dollars, and the average lifespan of the bill in years. So a $1 bill, they know that's going to last about 1.5 years. Then it's going to get so worn out it can't be used any longer. On the other hand, a $50 bill, that's going to last about 9 years. $50 bills, not as many people have $50 bills. They don't get exchanged as often, so they last a little longer. We're asked to create a scattergram of the data. That's part A. All right, so the first thing I notice here, all my numbers are positive, so I only need really the first quadrant. So I would tend to draw my scattergram like this. Okay? Now, we need what's called an independent variable and a dependent variable. Typically, the independent variable, when you're given a table like this, is the one that comes first. So the independent variable, or the x variable, if you will, is going to be the value of a bill. And our dependent variable, the dependent variable is typically what you're calculating. So that would be lifespan. Put that over there. And we label our axes like so. All right, now I've got to draw a scattergram. Now, how am I going to label my x-axis? Notice I got to start at 1 and I got to get all the way to 50. I don't really think I want to go by 1s. I don't want to have to go 1, 2, 3, 4, 5, 6 and draw 50 little tick marks. That would take too long. I think maybe what would be a good idea would be to go by 10s. 10, 20, 30, 40, 50. And I wrote value of bill too close, so I couldn't label all my tick marks, but usually I would have labeled them all. On my lifespan axis, on my y-axis, I got to go from 1.5 to 9. I guess I can label those by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I don't have to mark all of them, just enough so that the reader has an idea of what the scale is. So I'm just going to mark 3, 6, and 9. All right, so the value of a bill is $1, lifespan is 1.5 years. So $1 wouldn't be over very far, and 1.5 would be right there. So put a dot right there. 5, 2. So 5 years, or $5, 2 years. $10, 3 years. $20, 4 years. And finally, way over here, $50, 9 years. Okay, so there's the scatter plot. Okay, again, the scatter plot is just the data given. I would not connect these points with a line or a curve or anything. In fact, it really wouldn't make sense, because if I were to connect with a line or a curve, that would mean I want every point in between. I don't want every point, because there's no $30 bill. There's no $40 bill. I just want the data given. Don't connect it with a dot. Okay, part B said, explain why it makes sense that the average span of a $50 bill is greater than that of a $1 bill. I already kind of said that. The $1 bill isn't handled nearly as often, or the $50 bill isn't handled nearly as often. Part C, each year many more $1 bills are printed than 50. Give at least 2 reasons why this makes sense. Well, one would be the $1 bills wear out very quickly, and 2 would be lots of people have $1 bills. Not a lot of people have $50 bills. Okay, so that's a scattergram given some real data. I want to do a couple more quick problems out of the book here dealing with independent and dependent variable. So let's take a look at, I'm going back to page 20 here. How about number 22? All right, we have let P be the percentage of colleges that would accept a student whose grade point average is G. All right, and it asks, what's the independent variable and what's the dependent variable? The independent variable, the way I think of it, the independent variable is the one that you're usually going to know, and the dependent variable is the one that you're going to figure out. Okay, so in this problem, generally, it would seem to me as though what I'm going to know is I'm going to know my grade point average. I'm going to know my GPA. So it seems to me as though independent is GPA. And once I know my GPA, I can look up a chart or some sort of thing, I guess, to find out the percentage of colleges that would accept me. So dependent is P. Okay, that would be my answer. All right, last problem from this section, number 36. Let P be the percentage of airline tickets sold by U.S. travel agents that are electronic tickets at T years since 2010. And then they give us a point. The point is -2,98. And we need to describe what that point means in terms of the paragraph given above. Well, the first thing we need to decide which variable is dependent and which one is independent. Again, I'm looking at it, I'm thinking the thing I'm going to know is I'm going to know the year. So it seems to me as though independent is the year. And so that's T. The dependent is what I will figure out or what I will look up. And that would be P, the percentage. Okay? So what that tells me is independent variable always comes first in my ordered pair. Dependent always comes second. Think of independent as X, dependent as Y. So T here is -2. So in this ordered pair, I'm told T is -2, and P is 98. So what does that mean? Well, T is the number of years since 2010. But they gave us T is -2. So in this case, negative just means before 2010. So what this tells me is in the year 2008, and P here, this is my percent, 98% of tickets were electronic. All right, so that's what that ordered pair tells me. The first number is the time, the second number is the percentage of tickets.